We have already learned how to use kinematic equations to find out unknown quantity related to object which moves along straight line path and shows uniform acceleration. In this video also, we will discuss same type of numericals, but these are little difficult ones as compared to previous numericals that we have studied. I have selected these numericals from your exemplar book. Let us discuss first numerical. An object starts from rest, travels 20 meters in first 2 seconds, 160 meters in next 4 seconds. What will be the velocity after 7 seconds from the start? So to find out velocity after 7 seconds from the start, they have given you information of what happens in first 2 seconds and in next 4 seconds. So let us solve the numerical stepwise. Let us see what happens in first 2 seconds. So what all things are given for this part of the journey? Let us discuss. An object starts from rest. So what is initial velocity here? 0. It travels 20 meters. That means distance traveled is s, that is 20 meters. And in first 2 seconds, that means time duration is 2 seconds. So let us write down given things. After this, we have to find out velocity after 2 seconds. Ultimately, because we have to find out velocity after 7 seconds. So let us find out velocity after first 2 seconds. But to find out velocity, we have to use the formula v is equal to u plus at. But here we need to know the value of a, which is not given. What is the other formula with which you can find out velocity? V square equal to u square plus 2as. But to use this formula also, we have to understand the value of acceleration. So let us first find out value of acceleration using the formula s is equal to ut plus half at square. Here rest other things, that means u, s, t are given. That's why we have used this formula to find out a. So let us substitute the values, solve it further and get the answer of acceleration, that is 10 meter per second square. So after 2 seconds of motion, the object is moving with acceleration 2 meter per second square. Now using this a, we can find out velocity after 2 seconds. For that, which formula will you use? V is equal to u plus at. Now let us substitute the values. U0, A10, T2, 2 seconds. So after solving this, you will get velocity to be 20 meter per second after 2 seconds. So let us see what happens in next 4 seconds. Now if you have observed, object is moving with what velocity? It gains the velocity 20 meter per second after 2 seconds, right? So it is right now moving with velocity 20 meter per second. So at the start of 4 seconds, what will be the initial velocity? 20 meter per seconds. You have to understand this. It is simple logic. Then time duration is 4 seconds. Distance covered is 160 meters. So let us write down all these given things for next 4 seconds of the journey. So u 20 meter per second, t 4 seconds, s 160 meters. Now using this data available, here also we will check what is the acceleration of moving object. So how will you find out a when these things are given? Yes, the same formula. S is equal to ut plus half at square. Let us substitute the values, solve further and get the answer of a to be 10 meter per second square. So have you noticed that for this particular journey, a remains the same, constant. We are getting 10 meter per second square after 2 seconds of the journey. Even we are getting 10 meter per second square after 4 seconds of the journey. Now using this data, let us find out velocity after 7 seconds from the start. For that, now this is final velocity they are talking about. So which formula will you use? V is equal to U plus AT. So we are supposed to find out value of V, velocity after 7 seconds. And here one more very important thing you have to notice. They have asked you velocity after 7 seconds from the start. So what value of U will you take here? From the start means U is 0 because object is starting from rest initially, right? So from the start that means U is equal to 0. What is the acceleration body has achieved? 10 meter per second square. And what is T here? Time duration 7 seconds. So let us substitute the values and get the answer. V is equal to 70 meter per second after 7 seconds from the start. Now the next numerical. An object is dropped from rest at a height of 150 meters and simultaneously another object is dropped from rest at a height of 100 meters. What is the difference in their heights after 2 seconds if both the objects are dropped with the same accelerations? Acceleration is also given here, that is A is equal to 10 meter per second square for both the objects. Now let us see how to solve this numerical. What is the initial difference in the heights of the objects before they are dropped? One is dropped from the height of 150 meters and another from 100 meters. So initial difference in their height will be 150 minus 100, that is 50 meters, right? Okay, so they travel with the same acceleration too, and that also for same time. So logically, after 2 seconds or even after 4 seconds, the difference in their height would remain the same as before, that is 50 meters. But let us calculate the distance traveled by both the objects in given time and prove this fact. So let us calculate distance traveled by first object in 2 seconds. So what all given things are there for first object? Object is being dropped from the rest. So U initial velocity will be equal to 0, right? It travels for 2 seconds. So time is equal to 2 seconds and acceleration is given, that is 10 meter per second square. So with all these given things, how can we find out distance traveled by first object? Which formula we need to use? Yes, second kinematic equation, that is S is equal to ut plus half at square. Let us substitute the values, solve further and get the correct answer, and let us write down correct unit. All the units are given in SI system. So let us write down the unit for displacement or distance traveled in SI system, that is meters. Now we will find out distance traveled by second object in 2 seconds. For that also, let us see what all given things are. Second object is also being dropped from the rest. So U is 0 here too. It travels for 2 seconds, so time duration is 2 and acceleration is 10 meter per second square. So if you have observed, given things for both the objects are the same. So when we use the same formula to find out the distance, we will come across the same answer. So distance traveled by second object in 2 seconds is also 20 meters. So both the objects have covered the distance of 20 meters from the start. So now we have to find out difference in their heights after 2 seconds. So let us see at what height the first object is after 2 seconds. It is being dropped from the height of 150 meters and it has covered the distance of 20 meters. So it is at the height of 150 minus 20, that is 130 meters. Similarly, we can find out at what height the second object is after 2 seconds. Second object is being dropped from the height of 100 meters. So it has covered the distance of 20 meters in 2 seconds. So 100 minus 20, that is, it is at the height of 80 meters from the ground after 2 seconds. So the difference in their heights after 2 seconds will be 130 minus 80, that is 50 meters. This MCQ from your exemplar book is purposely selected here. I have observed many students find this MCQ little difficult. So let us see what is given here. A body is thrown vertically upward with velocity u. The greatest height h to which it will rise is, and then the options are given. But in the options, if you see, you can see the alphabet G. What is this G? G is nothing but acceleration due to gravitational force. They have said a body is thrown vertically upward. That means body is moving in air. And when body is in the air, which force acts upon it? Yes, gravitational force. So the change in speed of the body or velocity of the body is caused due to which force? Gravitational force. As a result, acceleration produced in the body is due to gravitational force. And instead of writing merely A stands for acceleration, they write it as G whenever acceleration is caused due to gravitational force. Okay, so here G is nothing but acceleration. We will know more about this acceleration due to gravity in some other chapter, gravitation. So let us come back to our numerical. If you have observed, they haven't given you any numerical value here, right? Given things are not in numbers, but still let us write down what is given here. A body is thrown vertically upward with velocity u. That means what? Clearly, they have stated initial velocity to be u. The greatest height it reaches is h. That means distance covered by the body is h. One more thing they have given indirectly. When object goes in upward direction, its velocity decreases slowly and a point comes when its velocity becomes zero. So when the object reaches the greatest height, its velocity becomes zero. That means final velocity v is zero here. So let us write down all these given things. Initial velocity u, that is what they have stated. Final velocity v, that is 0 because it reaches the greatest height, highest point, and they have stated greatest height h to which it reaches. That means distance covered is h. Okay, we are supposed to find out what is this distance covered or greatest height. So what is the formula we can use to find out distance covered by the moving object here? Yes, s is equal to ut plus half at square. But have they mentioned anything about t, that is time? No. So obviously this formula we cannot use. Then is there any other formula with the help of which we can find out distance covered by moving object? Yes. Third kinematic equation also we can use. What is it? V square equal to u square plus 2as. right? So let us use this. V square equal to u square plus 2as. So here instead of a, we will write down simply g, meaning is same. So let us substitute the given values. V is 0 here. Initial velocity is u. We will write down it as it is u square minus 2gs. Instead of a, I have written g. And one more thing. Have you noticed negative sign there? Minus 2gs. Why negative sign I have given here? Now object goes in upward direction. So slowly its velocity decreases. When it reaches highest point, its velocity becomes 0. That means final velocity is 0. An object is thrown with some initial velocity, right? So here final velocity is definitely lesser than initial velocity. So object shows negative acceleration or retardation, right? Deceleration. So here acceleration will be negative since final velocity is lesser than initial velocity. That's why g is negative and that's why it is written minus 2gs. Let us solve further. Let us take this u square to the left hand side. So it will become minus u square is equal to minus 2gs. So let us solve further. Let us take minus 2g to left hand side. Minus u square upon minus 2g will give you s. We are supposed to find out value of s, right? We are supposed to find out greatest height h to which it will rise. So after solving further, negative side will get cancelled out and value of s is equal to u square upon 2g. Let us see whether this answer is there in options given. Yes, it is. Option B, u square upon 2g is the greatest height